Hi everyone. So this is a problem related to the application of Muller-Bress law principle. So this is an indeterminate structure of continuous beam which has a span of AB 4 meter and BC 5 meters. So they have asked for calculation of ILD for RA. So in this type of problems, they only ask any one responses. In the previous problems we have seen, we have to measure all the responses, reactions, moments, shear force, all the things. But in this type of indeterminate structures, for the university problems, they'll ask only any one response. Either it is RA, RB, RC or moment or shear force, any one response. That will be the greater thing to solve. So we need to calculate the ILD for reactions. What is the Muller-Bress principle states? If what the response you want to plot, you just remove the condition and make it free and apply the unit load or unit rotation. So I'm making free of this A point. See, I'm just having only B and C. So this is a roller. So this is B and this is C. So where you have a reaction RB and you have a reaction RC. So I'm applying a unit load here, so of 1. So there is no such units, it's just a unit load. So 1. So we will find out the reactions at B and C. Taking moment at C, so equals 0. You take the moment. So 1 into the distance is 4 meter and this distance is 5 meter. So 1 into 9. So see, the section left side clockwise is positive and right side anti-clockwise is positive. So it is a clockwise direction, so it's positive. And RB is also clockwise. So RB into 5, which equals 0. So which you can say it as RB as minus 9 by 5. So which is minus 1.8. So which shows that RB is not in the upward direction. RB is in the downward direction, which is 1.8. So it's minus. So now you take summation V equals 0. So the total load should be equals to 0. So that is 1 and that is minus 1.8 and plus RC is equal to 0 since there is no total load. And so putting RC will be equal to 0.8. So the value is 0.8. So this is how we calculated the reactions. So reaction is one of the basic thing, and after that we will calculate what is the moment. So the moment, we need to take a section, wherever the section we can take a section X from a distance of right support and even the X here, the same distance at the support here. So now we will write based according to the Macaulay's method, so which is studied in the strength of materials. So taking moment at the section X, so the moment at X will be equal to 0.8 into X for this section, and for this section minus this is 1.8, right side anti-clockwise is positive, it is clockwise, so minus 1.8 into X minus 5. See, this distance is X minus 5. So this is the moment. So EI into d square y by dx square will be equal to minus of moment x. So which may be even written as 0.8 times of x plus 1.8 times of x minus 5. So this is the moment equation. So on integrating, you will get EI into dy by dx is equal to minus 0.8 x square by 2 plus 1.8 x minus 5 the square divided by 2. Again integrating, we will get the deflection equation. EI into y is equal to minus 0.8 into x cube divided by 6 plus 1.8 into x minus 5 the whole cube divided by 6. So this is the deflection equation. Now writing the boundary conditions, you may know the boundary conditions at x equal to 0. See, this is a support, so obviously y will be equal to 0 and x equal to 5. This is a support. So at x equal to 5, y is also equal to 0. So putting the equation at x equal to 0 and y equal, before that we need to distinguish this value. See, this is the point and this is the point. So this is lower limit 0. From 0 to 5, this equation alone exists, and 0 to 8, 0 to 9, this complete set of equations exists. We need to write it down. This is 0 to 5 equation and this is 0 to 9 equations. So see, it's 0. So since it's 0, only this equation alone exists and this equation alone does not exist. Since integrating, we need to also add the integration constant of integration C1 to the first point, since it is due to the Macaulay method. So for here it will be C1x plus C2. So you need to add only with the first term, not with the second term. So since at x equal to 0, y equal to 0, on substituting this, you can see, since x equal to 0, put x equal to 0, only the y equation 0, 0, so obviously the C2 will be equal to 0. There is no such relations. So substituting at x equal to 5, so 0 equal to minus 0.8 into 5 cube divided by 6 plus C1 into 5 plus 1.8 into obviously this equation is 0, since there is no need for you to even consider this one. On substituting the value, C1 will be equal to 3.36. So the final equation of deflection, EI into Y, is equal to minus 0.8 x cube by 6 plus 3.36 of x plus 1.8 into x minus 5, the whole cube, divided by 6. I am segmenting, though this is 0 to 5 and this is 0 to 9 equation. You need to keep in mind. So next, we need to find out the reactions RA. So RA is nothing but, we know that y of XA to that of y of EAA. So this is y of the x, since this is the equation made for the x section, and with correspondingly we have made a unit load at A. So this is y of XA. We need to find out what is the value of YA. So YAA is nothing but, put x is equal to, or substitute x is equal to 9 meters. So that distance are always measured from the right support. So if x is equal to 9 meter, y of XA will becomes y of EAA. So you just substitute wherever the x point as 9 meter. So here I am getting the overall value as minus 47.2. I have even calculated, since it is a longer problem. So I have calculated the values already. So now I substitute in the value, RA will be is equal to minus 1 by 47.2. Since you can see here there is an EI, and for this equation also there will be an EI. So this EI gets cancelled. So minus 47.1 by minus 47.2 into y of XA is 0.8 x cube by 6 plus 3.36 x plus 1.8 into x minus 5, the whole cube divided by 6. And this is the ILO, influence line ordinate for RA. So for these conditions, we need to find out the values. We need to substitute the x distances, 1 meter, 2 meter, 3 meter, 4 meter from x, and I'm finding out the IL plots. So x from C and ILO for RA. So this is 1, 2, 3, 4, 5, 6, 7, 8 and 9. Okay. So before going that, we need to write the equations for 1 to 5. Since there is a support 1 to 5, there is an equation in this. We have splitted this earlier. You know that the equation is 0.8 of x cube by 6 plus 3.36 of x alone. From 5 to 8, the equation may be, my equation is written as 0.8 x cube by 6 plus 3.36 of x plus 18 into x minus, sorry, it's 1.8, it's not 18. So 1.8 into x minus 5, the whole cube, divided by 6. Now substitute x is equal to 1 in this equation and you just write down the value. And 2, put x is equal to 2, substitute x is equal to 3, x is equal to 4. For this x ranges from 1 to 5, you need to substitute this equation, and the x ranges from 6 to 9, you need to substitute this equation. So I have already worked it out, and I'll write the intensity. So 0.07 minus 0.118 minus 0.135 minus 0.10, and for 5 it's 0, and this is 0.180, 0.42, and this is 0.702, and for 1. So now we'll plot the intensity. You see, I'm plotting this. So this is 0, this is 1, this is 2, this is 3, this is 4, and this is 5, 6, 7, 8, and 9. So for 1 it is minus 0.07, and for 2 it is minus 0.118, and for 3 it is minus 0.135, and for 4 it's minus 0.10, and 5 is 0, 6 plus 0.18, and for 7 it is 0.42, and for 8 it is 0.72, and for 9 it is 1. So you just join the points, and this is the ILD for RA. So this is how we are calculating the influence slide diagram for RA using Miller-Breslau principle. Thank you.